welcome back to another video. Today we'll be talking about the difference between scalar and vector quantities. Understanding the difference between these two terms will help you greatly as you move along in physics, because as you learn more and more variables, all of them will belong to one of these two categories. So let's go ahead and learn about them. Let's start with the simpler of the two terms, which is scalar. Now, a scalar is a quantity that is fully described simply by the size of the quantity, and you'll hear size used interchangeably with the magnitude of the quantity. It really just means how big a value is. The common way to represent how big something is would be with a number. So scalars are often represented with a number, and the larger the number, obviously the larger the magnitude or the larger the size of that value. An example of a scalar quantity would be mass, because mass can be fully described with just a number. Now that we've defined scalar quantities, let's go into vectors. Now a vector is a little bit trickier, but it's not too hard. It's just that it's fully described by both its magnitude, again, which is the size of something, as well as the direction that the object is moving in. Often vectors are represented with arrows because we can easily represent both size and direction using arrows. Specifically, the length of the arrow will represent the magnitude of it, whereas the direction the arrowhead is pointing in will represent obviously the direction of the vector. So how can you tell if a number or something that you're given in your physics problem is a vector quantity? Well, if you see a number paired with some kind of descriptor of a direction, like north, east, south, west, up, down, left, right, or even a positive or negative sign attached to that number, then you're probably looking at a vector quantity, because we're describing both the magnitude of the object, which is the number, the numerical value, as well as the direction that the object is moving in. Let's talk about an example of a vector quantity. A classic example of a vector quantity would be velocity. For example, to fully describe a velocity, you're going to need to both have the number, which is how quickly something is moving, that's the magnitude of the vector, as well as the direction the object is moving in. So again, we'd often use a plus or minus sign, but you can also describe if it's moving in some kind of cardinal direction, north, east, south, west, or it could be up, down, left, right. Some kind of direction has to also pair with the number in order for the vector to be fully described. So we can't just say that something's moving 25 miles per hour. If we do that, we're really just talking about a speed, because there's no direction. In order for it to be a vector, and also the velocity, since velocity is a vector value, we would need to say that it's moving 25 miles per hour south, or whatever direction it's moving in. Now, if you've defined north as positive and south as negative, or your physics teacher said that is okay, then sometimes you'll see that it's a negative 25 miles per hour. I know, some of you might be thinking, how does something travel in negative 25 miles per hour? And so that's a common misconception. Some people, because of math, would think negative 25 is a tiny number. How can someone be moving that slowly? But in physics, we have to separate both the negative positive sign and the actual number. The number represents the magnitude of the object. How quickly is it moving? So whether we say something's moving at negative 25 miles per hour or positive 25 miles per hour, it is moving at the exact same magnitude, the exact same speed. However, the velocity is different because of the positive and negative sign. Even though they're moving at the same speed, they're moving in opposite directions. One of them is moving to the right, the other one's moving to the left, or one of them is moving north, the other one's moving south, however it's been defined in your problem. In fact, this might be tricky, and I know that oftentimes my students get this mixed up too, but negative 100 miles per hour is actually faster than positive 25 miles per hour. I know in math, again, that seems counterintuitive, but trust me, that's how it works in physics. The number represents the magnitude, the direction is simply the positive or negative sign. So don't let that confuse you. So just to review, scalar quantities are fully described by simply magnitude, while vector quantities require both a magnitude and a direction to be fully described. I hope you found this video describing or differentiating between scalar and vector quantities helpful. If you did, please subscribe for more science videos just like this one. And until next time, always remember, this is fine and I can do it. Bye!